Today is day 1 of Unit 4, exponential functions. Exponential functions, and then we'll do sequences at the end. So for day 1, we're going to answer the question, how do we evaluate and graph exponential functions? So if you do not have your graphing calculator out, please get that out. We will be using that for this lesson. So the first thing I'm going to do is I'm going to do a paper folding activity. So, all this is saying is we want to know the layer of thickness depending on the piece of paper, okay? So now I have a piece of paper, okay? So what I'm going to do is I'm going to actually fold it, all right? So a piece of paper, the layer of thickness, we're going to say it starts off as 1, okay? Then I'm going to fold it once. Okay, if I fold it once, that means it's 2 layers of thickness now. Okay, if I fold it again, 4 layers of thickness. Okay, and then you can keep folding your paper. Okay, if I fold it 3 times and you hold it sideways, you'll see that it has 8 layers of thickness. 4 times would be 16 layers of thickness, and then 5 times would be 32 layers of thickness. So as it's going up, it is actually doubling. Okay, so if we were talking of a linear function, y increases by a constant amount. All right. As you see, this is not going up by a constant amount. That means I can add the same each time, but that isn't what's happening. I'm multiplying by 2, multiplying by 2. Okay, so each time I'm multiplying by 2. Yes, that is going up by a constant rate, but not by addition. So for a line, it has to be by addition. So because it's not by addition, this cannot be linear. Okay, so this is a non-linear function. All right. An exponential function, y is, let's see, multiplied. All right. So like I just said before I erase it, okay, it was going up by 2. So the way that we write this is y is equal to 2 raised to the x power, okay? So these would be my x's, all right? So if and you already have it on your paper, so if I do 2 raised to the 0 power, that equals 1. 2 raised to the first power, that equals 2. So if you notice, these were the numbers that we had when we actually did the paper folding. I'm just showing you that. And in case you guys do not know how to do this in your calculator, I will show you later. Okay. So the form of an exponential function is going to be y is equal to a times b, and b is raised to the x power. So the only thing being raised to the x power is your b value. So let's look at these examples and just quickly write down our a. So our a is going to be the coefficient, and then our b is going to be our base. Now the thing that they pointed out, it must be positive, all right? So whatever is being raised to the power, that's our b value. So always do that one first if you don't know what it is. And then if there's nothing in front, like there is for number 1, then it's just a 1. Now this one, again, this must be positive if we're talking about an exponential function. So b is actually 3, and then a would be -1. All right, so now what we're going to do is we are going to actually graph these. Okay, so we first have to talk about a little bit of notation. All right, so for this question, we have our function, okay, the one we just talked about. Now domain, remember, these are all of our x values. So when they do this, what I want you to remember is they are actually telling you where to start from. So they want all of the y values from -3 to +3. All right, so what I'm going to do is I'm going to set up my table, okay, and I'm going to go 3, 2, 1, 0, -1, -2, -3. Sorry. Okay. So now what I want you to do is I want you to go in your calculator and you're going to type in the function. So the function is 2, you're going to hit this 2, and then you're going to hit the caret button. Alright, the caret button is this button right here. And then I'm going to put an x. Alright. So first I'm going to go to the table, so second function graph. Alright, so now I'm going to get my values right off of here. Okay, so I have 0.125, 0.25, 0.5, 1, 2, 4, and 8. Okay? And again, I just got them right off of here. Alright? So then, before I even do the graphing, what I can do is I can do the range. So, notice this one started, let me erase that so you can read it. Okay, so this one started at -3. So we're going to do it in the same order that they wrote it in. Okay? So, oh, did I do that backwards? I did. Sorry, guys. Alright, now it matches. Okay, so then what I'm going to do is I'm going to write my range exactly in the order that my other range is in, because then I don't have to worry about putting my inequalities in the wrong way. So this means that from the range, or from the domain, -3 to 3, the range, which is the y values, would be from 0.125 all the way to 8. Now they are included, so that's why we have r greater than or equal to sign. Okay, and then the last thing is you're going to graph it, so you can take a look at the graph. Now the next thing I want you to notice is that I know that this looks like it touches the x-axis, but it doesn't. So it's going to get exponentially close but it will not touch. Alright, so here's what your graph should look like. So make sure you draw your graph. Alright, next one. Okay, so again, same thing. We're going to use what they told us, so x, y. So they want all the way from -2 to +3. Alright, so just how it's on here, I'm going to do parentheses, 1/2 x, oops, sorry, 1/2 raised to the x. So again, you do your little caret button, which is right under the clear. It's like that little up arrow. Okay, go to your table and copy down the numbers. So we start at -2, so I see that it is 4, 2, 1, 0.5, 0.25, and 0.12. Oops, 1, 2, 5. Okay, so the range is going to be 4 not from 4. You always want to start with your smallest number. So 0.125. There you go. All right. And your graph would look like this. Now, the other thing I wanted to point out is notice that I do not have arrows on the ends of these. Because we are only graphing this, we are only going to graph that, okay? So they only want us to graph this portion of the graph, all right? So make sure that you are not putting arrows, but keep in mind, this is not always true. It's only when they give the domain. So if they just asked you to graph this function, then you would have to do the whole thing, okay? So you'd have to draw little arrows. All right, so let's answer these questions. Okay, so how do these differ? So the big thing for these is y equals 2 raised to the x curves up, while y equals 1/2 raised to the x curves down. Okay, that's the number one thing. Also, so this would be growth, and this is decay. All right, the things they both have in common is they both have a y-intercept at 1. Okay, do you think all exponential functions share this point? I'm going to say yes, as long as a equals 1. So remember, think of y equals abx. So as long as this equals 1, then they will always go through that. Okay, and the reason is because anything raised to the 0 power is 1. Okay, so for example, okay, so again, if my y-intercept is at 1, that means that the coordinate is 0, 1. Okay, so x would be 0. So if I were to substitute an x into either of these, I would a 0, I would get a 1 every time. Okay, 2 more graphs. All right, so now that I've explained that to you, I'm going to show you the graphs. All right, and we'll just talk about them. Okay, so again, while you guys are doing these, you really should be putting them in your calculator. I'm really going to stress to you guys that you really need to get better at using your calculator. I think that some of you are not utilizing it the way that you should. So if you still don't know how to put stuff in your calculator, please let me know, because things are only going to get harder, and I really want you to have all of the anything possible that will make your life easier. Okay, so again, the domain tells me which exact x values I want. So I'm going to type this in. So again, 4, hit your little caret button, raise to the x. So all of these, if you haven't noticed, if it is an exponential function, you're going to have an x in your exponent. All right, x in your exponent. All right, so go to your table. All right, you see that we started at -2, so you scroll down. All right, you can see what I have right here. I have right here. You can double check with your graph. Sorry. All right, and again, it looks like it touches the x-axis, but it does not. Okay, it does not. All right, and again for this one, please make sure you put fractions in your parentheses. So 1/3 raised to the x. All right, a little harder to read. There you go. All right, remember, make sure if you have a repeating decimal, you always have to put a repeatant bar over it. Okay? And then you're going to graph it. You can see that if you're raising a fraction to a power, it's going to be a decay. If you have a whole number, an integer raised to the x power, it's going to be a growth. All right, and then that's how you write your all right, again, do not forget, we are giving you a specific domain, so you're going to have a specific range, and you do not have arrows on the ends of these. All right, so let's do this with a word problem. So, all right, the function 5t represents the number of rabbits in a population after t years. A realistic domain for this function would be what? All right, so let's talk about these. We've done questions kind of like this before, so this shouldn't be too hard. Okay, so this question, okay, can we have a negative number of rabbits? No. Okay, so same thing for this. Remember, all real numbers would be positives and negatives. Okay, so for these, so A and D, you can't have negative rabbits. All right, and if we look at one after that, let's see, for C, that one probably wouldn't be it either, because rabbits won't live 500 years. Not cooperating today, sorry. Okay, so our answer is going to be 0 to 10. That's pretty realistic. All right, next one, evaluate. So this one I just wanted to do because always got to be brushing up on our algebra. All right, so we want to know for this function, if x is equal to 3, what would this equal? So I'm just going to do some simple algebra for you. Okay, so don't forget your order of operations. Okay, parentheses, exponents, and then multiplication from left to right, adding and subtracting from left to right. Okay, so I'm going to do the parentheses which have exponents in them first. So I get, so remember, this is just notation on this side, so you're not doing anything with f of 3. So I'm just going to keep carrying this down. Okay, so 8 cubed is 512, and multiplied by 7 is 3,584. Just a reminder of this is really 8 times 8 times 8. Okay, that would be the expanded form. All right, and the last question. Sorry, you guys always know the first day is always the longest. Okay, so we want to know which one has a greater value. So I'm going to try f of 4. substitute that in. And then g of 4. We're going to see which one has the greater value. Okay, so in your head you should be thinking, well, whichever one has the higher exponent, that probably should be the winner. But we will see. Okay, so we always do our exponents first. 2 raised to the 4th power is 16. If I multiply 15 and 16 together, I get 240. Alright, that's probably going to be easy to beat. Let's see. Okay, so I get 110. Oh, what do you know? Also times 16. So I get 1,760. So make sure you answer the question. So the function g of x has a greater value for x equals 4. And that's all.